Hi dear, today we'll learn about how the images are formed by a concave mirror. Okay, there are some rules how the lights will be reflected when it is parallel to the principal axis, or when it passes through the focus, or when it passes through the center of the curvatures, or beyond and in between the curvature and the focus. Like that, some rules are there. Okay. How the light will be reflected, how the instant light will be reflected back. Okay, so there are 4 rules how the lights will be reflected back. Okay, so we are going to represent the light by a ray. In the starting of the class itself, we told that here we are going to consider the nature of the light as a ray. That means it travels in a straight path. Okay, right? So we are going to represent the path of the light by a ray diagram. Okay, we are going to put a ray like this, and we are going to show that the light travels like this in this path. Okay, so this is a ray diagram. So what is the first rule means? A ray parallel to the principal axis will pass through the focus after reflection. That means what? This is your principal axis. What is principal axis? The line which passes through the center of the curvature and the pole, right? This is your principal axis. If a ray is parallel to this principal axis, this is your principal axis, a ray is parallel to the principal axis, will pass through the focus after reflection. That means what? This is your instant ray. So you know that this principal axis passes through the focus. So the focus point will lies between this, lies on the principal axis, right? So this is your instant ray. You know that as per the law of reflection, the instant angle of instant is equals to the angle of reflection. See which one is the normal for this curve. This is your normal. This is your normal. This is your instant light. So same angle will be here. So take this as this. This is your R, angle of reflection. Okay. So this is your focus point. Okay, clear on this? So a ray parallel to the principal axis will pass through the focus after reflection. Okay, this is the first rule. Whenever the ray of light parallel to the principal axis, it will reflect it back, pass through the focus point only. Okay, next rule. The ray incident through the focus. So reverse of this first rule. The ray incident through the focus, after reflection it will be parallel to the principal axis. So in the first rule what we are saying, if the ray is parallel to the principal axis, it will reflect it back through the focus point. If the incident rays pass through the focus point now, it will be reflected back which will be parallel to the principal axis. So this is your P, this is your C, this is your F, focus point. So if a ray is passed through the focus point, okay, pass through the focus point. So this is your instant ray, right? This is your instant ray. The ray is instant pass through the focus point and strikes the mirror here. This is your normal. So this is your angle of incidence, and what will be your angle of reflection? The same angle, it will be here, right? So this is your angle of reflection. Okay, when the ray of light incident through the focus point, it is reflected back which is parallel to the principal axis. See, clear on this? Okay, when it passes through the focus, it will be reflected back which is parallel to the principal axis. Clear on this? Next, the ray passed through the center of curvature is reflected back on the same path. It's very simple. So this is your C, this is your P. If a ray is passed through this center of curvature, what is the normal to this point? This is normal to this point. So your angle of incidence is I is equals to 0. So R will also be equals to 0. So it will be reflected back on the same line. Clear? So when a ray is passed through the center of curvature, it will reflected back in the same path because I is equals to 0. Therefore R will also be equals to 0. Excuse me. Okay, next. The ray incident on pole is reflected making equal angle. So the ray incident on pole, which one is here? This is your pole, this is your center of curvature. For example, if the ray incident on the pole like this, right? So your normal to this pole is what? This is your normal to this pole. How much angle it makes? This is your angle of incidence. So the reflected angle also will be the same one, R. This is your I and this is your R. So the incident ray on the pole reflected making the equal angle. Okay, this is your fourth rule. Okay, clear on this? Whenever you are drawing, you are going to get the image of the concave mirror, you have to follow the rules. Whenever it is parallel to the principal axis, it will definitely reflected back through the focus only. Whenever the incident ray is passed through the focus, it will be reflected back, which is parallel to the principal axis. Whenever the ray is passed through the center of the curvature, it will reflect back in the same path, center of the curvature. Whenever the incident ray is passed, incident on the pole, it will make an equal angle, right? That's it. So we'll see how the images are formed. How the images are formed in the concave mirror. There are 6 positions. 6 positions in that. For example, this is spherical. This is your mirror, means this is center of curvature. This is the pole. Center of curvature C. This is F. So what are the possibilities of the objects placed here? So the object may be placed at infinity. The object may be placed at the infinity. The object may be placed at the beyond C. The object may be placed at C. The object may be placed between C and F. The object may be placed at F. The object may be placed in between F and C. These are the 1, 2, 3, 4, 5, 6. 6 possibilities. Okay. 6 position of the object. Okay. If these excuse me. So based on this position, how the images will be formed, we are going to see that only. Okay. So first we will take the position of the object at infinity. Okay. How the nature of the object will be and how the size of the object will be, everything we are going to draw now. So this is your pole, this is your center of curvature. When the object is at infinity, somewhere, so you will get only the rays of the light path will be parallel to the principal axis, right? This will be parallel to the principal axis. This is parallel to the principal axis, right? When a ray of light is parallel to the principal axis, how it will be reflected? See how we flip. What is the first rule? It will be reflected back through the focus point, right? So it will be reflected to the focus point F. So it will be like this one, right? Okay. So your image at least you need 2 rays to get an image, where the image will be formed, how the image will be formed. Okay. For example, if you need to draw a line, you cannot draw a line with a single point. At least you need one more point to show that that line is moving in this path, right? Endlessly it can move in both the direction, but you need 2 points to make a line, right? Likewise, to get the image, at least you need 2 rays. With a single ray you cannot find where the image will be, how the size of the image will be. That's why I have taken two parallel lines. It both meets at the point F. Okay, both meet at the point F. So where will be the position of the object? Position of the image? Position of the image at focus point. At focus. Okay. What will be the nature of the nature of the image? It will be, for example, this is. For example, this is the head of the object, means it will pass through this, and the same head will be reflected here. Okay, so if this is here, means it will be reflected back. So you can it will be, this is one, it will be reflected back here like this. You can draw like this so many parallel lines and it will be reflected back. You will get a real, and head means the head will be placed here. It will be real and inverted. If you draw more than two lines, means you will be getting confused. So only two rays are enough to get the image. Okay. So I have drawn one more line to show that. So this head strikes here and it will be pointed here. You will get an inverted image. Okay. What is the size of the image? Everything focused at a point. It is a point sized. It is a point. Okay. Yeah. It will be a point size, diminished one. Diminished size. It's look like a point. Okay. So when the object is at infinity, you will get the image at the focus point, which is real and inverted, and it is point sized. Okay. Next one. When the object is beyond C, this is a C. When the object is beyond C, and this is your pole, okay, beyond C. So we'll take one ray which is parallel to the principal axis. Okay, so definitely if it is parallel to the principal axis, it will be reflected back through the principle of focus, right? Focus point. Okay, this is your F. One more ray, when the ray is passed through the center of curvature. When the ray is passed through the center of curvature, you know that when the ray is passed through the center of curvature, it will be reflected back in the same path. This is reflected back in the same path. So the meeting point of this is your reflected line. Again, this is your reflected line. Both are meeting at this point, right? This head is reflected here, right? So you will get a image here. Okay, you will get a image here. So what is the position of the image here? The position is it lies between the focus point and the center of the curvature, right? It is between focus and center of curvature. Then what is the nature of the image? Real and inverted. What is the size of the image? It is diminished. It is small in size. Okay, clear on this? When the object is beyond C, the image will be lies between the focus point and the center of curvature, which is diminished in nature. Clear on this? Okay. So you can take the same case when the object is if you draw the rays when pass parallel to the principal axis as well as pass through the curvature, you will get a diminished, real and inverted image which is in between C and F. If you take if you take the same beyond the object is placed beyond the C, we take ray which is parallel to the principal axis and also the ray which passes through the focus point, right? If the ray passes through the focus point, then what is the rule? It will be reflected back, which is parallel to the principal axis. See, this is your reflected line, this is your reflected line, both meets at this point. Again you get a inverted real image which is diminished, which is between center of curvature and focus. Okay. You can take same, the object is placed beyond C. It is parallel to the principal axis. The ray is parallel to the principal axis, reflected back through the focus point. Another ray we are going to take which is incident on the pole. If you incident on the pole, the angle of incidence is equals to angle of reflection, right? It will make a equal angle, right? Some more data has to come here. So both the reflected lines meet at this point, intersect at this point. See, again it is lies between focus and the center of curvature. The image is inverted and it is diminished in size. Okay, you can take any case. Okay, so usually we take for drawing easily, we have taken that which is one of the rays parallel to the principal axis, another ray passes through the center of